Hello, good morning, Jai friends. Today we are going to learn Chapter 1 Real Numbers of NCERT. Let us discuss exercise 1.4 of NCERT along with its solutions. Here, question number 1. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating. In order to prove that first question, 13 upon 3125 have a terminating or non-terminating decimal expansion, first we find the prime factors of 3125. First we find the prime factors of 3125 using prime factorization or long division method. 5 6 are 30, 5 2s are 10, 2 is remaining, 5 5s are 25. 5 1s are 5, 5 2s are 10, 5 5s are 25. 5 2s are 10, 5 5s are 25. 5 5s are 25. 5 1s are 5. Therefore, the prime factorization of 3125 is like this. We get 13 upon 5 raised to the power 5. We can write it like this also, 13 upon 2 raised to the power 0 cross 5 raised to the power 5. Therefore, the number who have 2 and 5 in its denominator is always terminating, whereas the numbers who don't have 2 and 5 in its denominator, they are non-terminating. In this number, we both have 2 raised to the power 0 and 5 raised to the power 5 in its denominator. Other numbers are not present, only these two numbers are present, therefore it is a terminating decimal expansion. Now comes to the next question. We have 17 upon 8. We can write 8 is equals to 2 raised to the power 3. 2 raised to the power 3. Here, we can write as 17 upon 2 raised to the power 3 cross 5 raised to the power 0, which is also have 2 and 5 in its denominator. Therefore, it's again a terminating decimal expansion. Now, let's come to the third example. 64 upon 445. We can write 445 as 5 cross 7 cross 13. Its prime factorization is 5 cross 7 cross 13. Other than 2 and 5, 7 and 13 are also present in its denominator. Therefore, it is a non-terminating decimal expansion. We can write this as 64 upon 2 raised to the power 0 cross 5 raised to the power 1 cross 7 raised to the power 1 cross 13 raised to the power 1. Other than 2 and 5, it also contains 7 and 13. Therefore, it is a non-terminating decimal expansion. Now, let's come to the third example, 15 upon 1600. We can write 1600 as 2 raised to the power 6. On finding its prime factorization, we can write it as like this. 2 raised to the power 6 cross 5 raised to the power 2, where m is 2 raised to the power m is equals to 6. 5 raised to the power n is equals to 2. It only contains 2 and 5 in its prime factorization. Therefore, 15 upon, we can write it as like this, 15 upon 2 raised to the power 6 cross 5 raised to the power 2. It contains only 2 and 5 in its denominator. Therefore, it is a terminating decimal expansion. Now, let's come to the fifth example. Here we can write 343 as cube of 7. We can write it as 29 upon 343 as like this. 29 upon 2 raised to the power 0 cross 5 raised to the power 0 cross 7 cube. These two numbers are not present in its denominator, only 7 is present in its denominator. Therefore, the given question is not terminating, it is non-terminating and repeating decimal expand. It is non-terminating and and repeating decimal expansion. Now let's come to next example, 23 upon 2 cube cross 5 square. In order to prove that this is a terminating or non-terminating, first go to the denominator of the given fraction. The given denominator of the fraction contains 2 and 5 only. Therefore, it is a terminating decimal expansion. In next question also, first go to the denominator of the given fraction. It also contains 7 raised to the power 5 other than 2 and 5 in its denominator. Therefore, it is non-terminating and repeating decimal expansion. Question number 3. The real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are Q by Q, what can you say about the prime factors of Q? Here we have to find whether the given expansion is terminating or non-terminating, whether they are rational or irrational. If they are rational, then we have to say that for what about the prime factors of Q? Here in first question it is given that in first question we know that this is a terminating decimal expansion, means whatever is the value of Q, it is in the form of 2 raised to the power m and 5 raised to the power n. Therefore, the prime factors of Q will be either 2 or 5 or both. It may be contain 2, it may be contain 5, or it contain both the values 2 and 5 because it is a terminating decimal expansion. How it's a terminating decimal expansion? When we write 24.2, 3, 4, 5, 6, 7, 8 and 9. When we remove this dot, we write it as 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. We put here 9 zeros. Therefore, we can write it as like this also in the form of 2 and 5 where for some value of m and n. Therefore, it is a terminating decimal expansion. It is non-terminating because the value is continued to be. It is not stopping. Therefore, it is a neither terminating nor recurring. Therefore, the given expansion is irrational number. Therefore, the given expansion is irrational number. Thanks for watching. Don't forget to like, share and subscribe my channel.